we're going to do in this problem is write out the formula for the thing we're asked to find. We're asked to find cosine of u minus v. So we look up that formula, and it says cosine u, cosine v, plus sine u, sine v. So this example is the same type of problem as the last example that we did in yesterday's lesson, just to kind of remind us of the way it was working. We had 3 types of problems. The first type of problem in our lesson yesterday was when we were given an angle, something like 75, and we needed to come up with 2 angles that we knew about, either from special triangles or unit circle, that we could add or subtract to get that. So like 75 is 45 plus 30, and those are special triangle numbers. So that was our first type of problem yesterday. And our second type of problem was the same as this type of problem. So we'll do one of these to kind of refresh on how they work, and then we'll have one more type of problem to look at before you head to your assignment. So first step is to write out the formula, remembering to be careful of u's and v's, and that you can tell the difference between what a u is and what a v is, since it does make a difference. So then on our next step, what we're going to do is find out some information about u. So angle u is between 0 and pi halves, so which quadrant is that? The first quadrant. So somewhere in that first quadrant I have an angle u, and that angle, we're told, has a sine of 1/5. What's SOHCAHTOA for sine? Opposite over hypotenuse. So that means I have an opposite of 1 and hypotenuse of 5. This is not a special triangle. So how do I find the third side? Pythagorean theorem. So b squared plus 1 squared equals 5 squared. So b squared equals 24, which is not a perfect square root. We don't want decimals, so we need to break that down. What goes into 24? 4 and 6. So we get 2 square roots of 6 for that third side. So no decimals. If it's not a perfect square root, break it down if possible, and if not, just let it be. Then we're going to do the same thing using the information about angle v. So angle v is between pi and 3 pi over 2. So which quadrant is that? 3. And it has a sine also, so that's opposite over hypotenuse of -5 and 13. So the other side will be -12. This is a special triangle, but if you don't recognize it, you just do the Pythagorean theorem every time, and it'll always get you that third side. But if you can learn to recognize them, it's a good time saver. So now we know everything there is to know about the triangles u and triangle v. So we can use those to evaluate the things in the formula. So cosine of u, I look at the u triangle. Cosine is adjacent over hypotenuse, so that's 2 squared is 6 over 5. Then times the cosine of v, look at the v triangle, adjacent over hypotenuse is -12 over 13. Plus the sine of u, we could either look at the sine triangle and do opposite over hypotenuse, or that was actually our given information, that sine of u was 1/5. And also then for v, looking at the v triangle or looking at our given information, sine of v is -5/13. Don't do any reducing, even if it's possible at this point. Just do our multiplications straight across. So I'm going to do 2 squared of 6 times -12. How do I do that? Multiply the outside stuff together, and then let the insides be. If you multiply 2 square roots times each other, multiply the inside stuff together. So outside stuff times outside stuff, inside stuff times inside stuff. In the bottom, we multiply and get 65. Then we get -5 over 65, which could be reduced, but don't, because at this point we have a common denominator, so that means we can put it all together over that denominator. And that's our final answer.
can't do the negative 24 minus 5, right?
Right, we can't do the negative 24 and the 5 together because it has that square root of 6, so they're like not like terms. It's kind of like one of them has an x and one of them doesn't. Right? Yes?
If the problem, like the sign in the middle, was a subtraction, you would actually add that?
Right, so if this formula had a subtraction in the middle of it instead of the addition, then we would have a double negative, so that would make us add then. Yep. Our final type of problem just says to simplify. So we're going to write out the formula using the x and the theta, or the x and the pi. So we have cosine and subtraction. So we would look up difference formula. The cosine one says cosine of first thing, cosine of second thing, plus sine of first thing, sine of second thing. Okay, so difference formula for cosine says to do the cosine of each of them plus the sine of each of them. X is a variable, so we can't do anything with x, but pi is a number, and specifically since we're thinking about trig, it's an angle. What angle is pi? 180. So 180 in the unit circle, or pi in the unit circle, is out to the left. What's that point? Negative 1, 0, which gives us what trig values? Cosine, comma, sine alphabetically. So back when we learned about our unit circle, we learned that we could label the points on our axis lines and that those points would give us the cosine and then the sine. And what was tangent? Sine over cosine. Okay, so if we would ever need a tangent, we could do a sine divided by cosine. So then, cosine of x, again, that's a variable. We can't do anything with that. But cosine of pi is what? Negative 1, taking the cosine part of that point at pi. Sine of x, that's a variable. We can't do anything there. But what's the sine of pi? 0. Negative 1 times cosine is negative cosine. 0 times anything is 0. So we're left with just a negative cosine. So we apply the formula, and then the part that has pi stuff in it, so the part that has an angle in it, we use our unit circle to evaluate. Questions? One more of this type. So this one's adding. So we look under the sum formulas for sine, and it says do sine of first, cosine of second, plus cosine of first, sine of second. X is a variable, so we can't do anything with x, but pi has an angle. What angle is it? 90. What's the point at 90? 0, 1, which is our cosine, comma, sine. So then in our formula, sine of x is a variable, can't do anything with it, but cosine of pi halves is 0. Cosine of x is a variable, but sine of pi halves is 1. Grabbing those parts of that unit circle point. Cosine is the first part and sine is the second part. 0 times anything is 0. Cosine times 1 is just cosine. What these questions are doing is to relate it back to the graphing part of our unit. If we were to graph this original problem of sine of pi halves plus, or of x plus pi halves, what does that plus pi halves do to our graph? When we did graphing our trig functions, what did adding something to the x do? That's like 2 weeks ago, guys. So if I was graphing y is equal to sine of pi halves plus x, or x plus pi halves, either way, what does that plus pi halves do?
Oh, it moves it to the left.
Moves it to the left, right? Something added to the x in the parentheses moved it to the left. So what this says is taking the sine graph and bumping it to the left of pi halves will make it look exactly the same as a cosine graph, because we found that those two things were equivalent, which makes sense if we think about sine and cosine are both waves. So if you bump a wave over a little bit, it's bound to start looking like the other one, right? So this says if we bump that sine back by a pi halves, it's going to start looking like a cosine.
So the cosine of pi halves and sine of pi halves became 0 and 1?
Yes, the cosine of pi halves and the sine of pi halves became 0 and 1 because those are the values of them from the unit circle. So we grabbed their unit circle values and plugged them in. All right. So your homework is from 14.6 today.